Hello YouTube, N3SDO here with another video. Today I have a troubled Wacom UHF bandpass cavity. I'm going to show you how I confirmed the problem, the repair techniques and tools that I used, and how I aligned and tested the unit after repairs. So let's meet our subject. It's a Wacom WP-494 adjustable coupling bandpass cavity. It's a rather small unit, about 10 inches long. The coupling loops turn to adjust the insertion loss and bandpass shape. They're calibrated in decibels. Inspection-wise, the frequency adjusting screw looks pretty good. Let's put it on the Nano VNA and check it out. Here I'm turning the adjusting screw and tapping on the can. It's producing noise in the pass band. At some points the peak just disappears. Yeah, it's broken. It's going to need to be taken apart for repairs and to inspect the other components. The only way I've found to put these devices back into service is to melt the solder off the bottom and remove the bottom of the can. It can be quite a task to do this, but this is necessary to get the plunger out. I start by wire brushing away some of the paint that's along the seam, as this will burn during the heating prior to the disassembly, and it'll need to be repainted later. I stand the can up on bolts that allows me to heat it from the bottom and still be able to pull the upper part of the can off, as the bottom can be a tight friction fit alone with being soldered. Once I get the bottom off, the plunger can be unscrewed from the cylinder. It's a long screw, it takes a while. Okay, yeah, we've got it out. Yeah, that's pretty yucky. And what you can't see from the photo, it's also very rough to the touch. The spring contact fingers look mechanically okay, but they're going to need to be cleaned up also. As you can see, the plunger's looking pretty good now. I've been working on it for a while to get it this pretty and smooth. Part of the reassembly, I give it a good bath in Fader lube to put a oil coating on it and protect the copper. Here I'm shown shooting a little more Fader lube to lubricate the contact fingers as it's being reassembled. Also using some deoxit on the end connectors and clean the coupling loops. It's a simple yet effective design for these coupling loops, and it works pretty good. Here I'm checking it on the Nano VNA again before putting the bottom on. This is the response with the bottom off, just with the plunger inside the cavity and the coupling loops installed. Back in the shop, I've left the bolts in the bottom to assist in the reassembly. It's similar to the disassembly. I've added a little dab of flux around the rim, heating it up here to get it to melt, and then have to reheat the base and the cylinder to get the solder to melt and get them to mate together again. Now here I have it on an Agilent spectrum analyzer with matched cables that is more accurate than the VNA. I'm adjusting the center frequency and coupling loops to get a good sharp peak with deep side slope rejection, but I don't want to create excessive bandpass loss. Here you can see the effect of rotating the coupling loops and how it changes the filter shape. At this point I'll be measuring the response above and below the target frequency. I've got 27 dB or even more at 10 megahertz out on each side. Looks good to me, so I will wrap this up at this point. Thanks for watching. 73's N3 SDO.